Hello everyone, this is Professor Chan speaking for Math 1245. We're going to start with section 4.2, okay? 4.2, we're going to talk about this concept called logs, okay? Um, we're going to talk about certain properties and then how to graph logs for the following. Okay, so let's talk about this right here. So logs is kind of an odd concept to explain, okay? The best way we can understand is logs is essentially an inverse of an exponential, okay? So if I have an exponential, okay, right, my inverse would be a logarithm. Okay, sorry, let me zoom in. Oh, okay. Okay. Yeah, and a way to read this is, and this is also in the PowerPoint too, but when you, a way to read logs is think of it as opposite. So what power would give you x, okay? We'll explain this a little bit more, okay? The idea is essentially logarithm is kind of backwards or the inverse of an exponential. Now, there are several types of exponentials and several types of logs, okay? So, generally, when we have a log, it's always going to be something like this. So it's be log, and I have a base a of x, okay? Sometimes there are some small exceptions. So the first one is if you don't see a subscript or a base, right? So if I don't see a number below, I assume it is base 10, okay? And if I see natural log with no number below, I assume it is base e, okay? Okay. But if I have something like log of 5 of x, right, this would be, my base would be 5, okay, for the following here. Okay. So let's talk about the following, okay? So we have to practice knowing how to essentially swap going from exponential to logarithmic functions. So actually, let me just zoom in more. Okay. So you'll have a situation like this where they'll give you exponentials, a statement that looks like an exponential or a statement that is logarithmic, and then they would ask you to flip them around, okay? So how do I go from exponential to log and vice versa, okay? So let me show you this here, okay? So for an exponential function, or sorry, an exponential statement, okay? This is what I'm going to do. So I have 9 is equal to 3 squared. So whatever your exponent is, it's going to switch out with your base. Okay, let me do a skinnier one. Sorry, my apologies. Yeah, let's make this a little bit skinnier. Okay, so if I have 3 squared and 9, the 2 and the 9 will swap. Okay, so the idea is your exponent and then the item by itself will swap, and it's going to look like this. Okay, so it's going to be the following. The 2 will go on the other side, right, because it'll swap, and it'll be log base 3 equals log base 3 of 9, okay? So let me explain this to you once again. The exponent and the number by itself will swap. So this 2 will swap over here. The 9 will essentially be an exponent of your base for your log, okay? Another way to think about this is a number that does not move becomes the base for your log, okay? Now, let's do this one right here, number 2. So the exponent will swap places with the item by itself, which happens to be 40. So the way this is going to happen is, so notice the 3 here doesn't move either, so that will be the base for your log. The 40 will go on top, and then the x will be by itself like this. Okay. Be very careful with your equal signs too. So notice the left and right hand side of my equals essentially stays the same, but just remember, right? So your exponent and the number by itself will swap, and then the number that stays becomes a base for your log. Okay. Now let's talk about this right here. What do I do with it going the other way? So if I go from logarithm to exponential, I'm going to swap 2 numbers again, or 2 items again. So the item by itself will also swap with the exponent for my logs. Okay. So the -2 will now become the exponent for 3, and the 1/9 will be swapped by itself. Okay. Now, if you notice, just like the ones before, the item that does not switch ends up being the base again, only it's the base for my exponent. So the thing that always stays ends up being your base, whether it's for your exponent or for your logarithm. Okay? And then notice the number by itself and, the item by itself and the exponent will switch around. Okay? Let me show you another example. Log base 2, 6 equals x. So notice this 2 will not switch. It's the number on top, and the item by itself will swap, and they will reverse roles. Okay? So the 6 will become the item by itself, and the x, which was by itself, will now become the exponent for 2. The 2 doesn't move. Okay? So it ends up being the base. Make sure you practice these. These can get a little tricky. Okay, now if you're not comfortable with this, okay, don't worry too much about this. I mean, you do have to practice, but there is another way to do this, and I'll show you this in a bit. Okay, so now if I look at number 5, notice I don't have an item on the bottom. It's natural log. So natural log, remember, we assume is base e. If it's log with no number, we assume it's base 10. So the way that you can write this is you can say this is base e. So then your x and the 4 will swap. The x will be by itself, and then it'll be e to the 4th. Sorry, my bad. And this will be my answer right here. Okay, so hopefully that should be relatively straightforward, but once again, if you have questions, let me know. This right here, you do need to make sure you practice this quite a bit so you understand this pretty well. Okay. But yeah, if you have questions, let me know. But yeah, so once again, this does take a decent amount of time to kind of get used to. Okay. So one thing is, if you have an exponential function, you'll have a logarithmic function, because remember, they're both backwards of each other. And so we can use this swapping game, right, where I'm swapping things around to help us solve values. So let's look at some examples here. Let's do a couple of these. So let's look at number 1. Let me rewrite this. This is x is equal to log base 2 of 1, okay? And the reason why this is important is because, right, I can't solve this. This is a little confusing. You guys don't even know how to do logs yet, okay? But if I swap it to exponential, this makes things a lot easier, okay? So remember our rule, right? This number stays the same, but the item by itself will swap with my exponent. And what happens, right? This becomes 2 to the x is equal to 1, right? My 1 swaps out by itself, and then the x, which is by itself, swaps in as an exponent, okay? And then How do we do this? Okay, later on, there'll be other techniques that will be easier to solve. But for now, right, you can kind of guess. You're like, what 2 to what power gives me 1? And you should realize it's 0. But if I put in my calculator, 2 to 0 does give me 1. Okay, so let's say x is equal to 1. Sorry, x equals 0. Okay, and that's my answer here. Okay. Okay, let's look at another example. Let's look at number 3. So same thing. I'm going to rewrite this because I know this looks a little funny in the typed version. So I'm going to swap and switch my items once again. Remember, the base never switches. So what does this look like? This looks like 243 is equal to 3 to the x. Okay. And if you're not sure, throw in your calculator. Here's a trick too. So let's say you think it's 3 cubed. Right, it's not, it's 27. You just have to keep increasing by 1 until you'll get it. Notice it's going to be 3 to the 5th. So my answer here will be x is equal to 5. Okay. So the swapping method is helpful because it actually helps us solve. I'm kind of transitioning it into an equation that's a little bit more reasonable, and that's easier to kind of see. Okay. Right now we're not going to be kind of sufficient in reading logarithms yet. So kind of the better way is to kind of switch it back out to exponents. Okay. And you know what? Yeah, let's actually do a couple more. Let's do number 4 and 5. So number 4, I have x equals natural log e cubed. Notice I don't have a base, so I have to realize it's base e. Now when I swap it, both of these, both the e cubed will switch out with the x. So it's going to look like e cubed is equal e to x. I realize they have the same base, so this will be x is equal to 3. Okay. Okay, so let's look at number 5 here. Yeah, so this one's a tricky one. So I have x is equal to log base 5 of cube root of 25. So when I swap, it's going to look like this here. The whole cube root 25 moves out. This will be cube root of 25 is equal to 5 to the x. Okay, now this one's a little tricky, so let's talk about this right here. Okay. What I'm going to do is I can write 25 as 5 square. So this is cube root of 5 square is equal to 5 to the x. Okay, now let's talk about this. Some of you guys may have forgot, but remember, if you raise something to a root and a power, you can write it in fraction form. This is the same thing as 5 to the 2/3. Right, because your power is your numerator, and then your root is your denominator. So I'll rewrite this as this becomes 5 to the 2/3, and then equals 5 to x. So this will be x is equal 2/3. That's it. Okay. Yeah, some of these will be a little bit tricky. Try to practice these, but if you run into trouble, feel free to send me an email. Okay. For the following. Let's talk about a couple more properties dealing with logarithms. So I'm going to move on to the next page. Okay. So these right here, make sure you know these 3 right here. This is important. So if I have log base b to the 1 equals 0, it will equal to 0. If I have log base b to x equals x, b log b x equals x. These 2 right here are actually really helpful because it helps us simplify our answers. Okay, an easy way to remember this is if you have the same base, so notice I have the same base of b, and then my exponent is also b, it just essentially cancels out. If I have if I have a base b raised to a log base b, then it cancels as well. Okay, so And then part 1, if you don't understand why that's true, if you swap it, you'll end up having beta 0 equals 1, right? Because if I swap these, right, this actually holds true. This is what I'll get, and that's a true statement. Okay? Okay? And so the idea is, this is actually pretty straightforward to do, and so it's easy to simplify. So I have same base of 5 raised to an exponent of 5. Essentially, it cancels out. I'm left with 3. Okay? And then same thing with number 2. 2 with raised to the log base 2, it cancels out. This is 3. Okay. This right here essentially becomes 1. Okay, why is that? Because remember, 9 to the 1 power is 9, so it cancels out. I'm left with 1. Okay, sorry, my apologies. 2 is, so number 1 is 3, number 2 is 3, number 3 is 1. Okay. Okay. So these two properties are also helpful. So let me kind of go backwards. Okay, I'm going to go back to the problem we just did on the first page. Okay. Okay. So let me erase this. So here's your thing too. If you do not like the swapped version, like switching your things around and you're in logarithmic form, let me show you another way to do this, okay? So remember, the rule is if you have the same base as your exponent, whether it's, you can cancel it out, okay? So let's look at this one right here, number 3. What I can do is I can raise them. I can do it like this. So the left-hand side, I can slip in a base of 3 like this. Okay. Why can I do that? Why do I want to do that? The reason why I want to do that is because it's going to cancel out, right? The 3 will be raised to the log base 3. Those will cancel each other out. I'm left with 1/9. Now the thing is, I obviously can't just arbitrarily do that. Okay, so if I'm doing base 3, raising with a base 3, right, on the left-hand side, I have to do it to the right-hand side, like this. Okay, so if you notice, this left-hand portion cancels out. It's left with 1/9, and I end up with 1/9 equals 3 negative 2. And that is what we actually have for 3. Do you guys see that? So this is actually another way to do this, okay? So I can use the raising the same base number and it'll cancel out. Let me show you one more time. For example, number 4. So in order to get rid of the log base 2, I'll raise it using base 2. So I go like 2 log 2, 6. This will cancel, I'm left with 6. Now remember, I can't just arbitrarily do that. I'll do that with base 2 to the x. So what's left? I'm left with 2 to x is equal to 6. That's what we got for part 4. Okay? So you can use the base cancellation rule. Okay, let me show you again. And make sure you write this part down. The one with b log bx, or you can do log b bx. Okay? They both will work. Okay? Or you can use a swapping method on the first page. So why don't we end here? We're going to come back. We're going to finish the rest of section 4.2. But other than that, I'll see you guys later.